So the recording started. I just handed the paper, exam one, and I uploaded the solution manual for exam one in Brightspace. If you have a chance, please take a look. Mostly everybody did well. Well means not like A. Uh, Mostly everybody in average got B or above. There's some A's as well, obviously. But if you just to give you a highlight here, if you submit the homework sometime, even if you don't get A on the exam, you may get A on the final grade. You know how? Because the homework grades, the class percentage, the class performance, all those things, if you get full points out of it, and those are very easy to get full points on those back, right? There are like 8 homeworks, if I'm not mistaken. There could be 9. Last year, I had 8. I may increase. In statics, I usually give 10. So maybe there could be 9, not 10 maybe. So out of them, 5 is already on the market, right? So you're probably working on homework number 5. So I forgot, maybe like 9 homework at least. Okay, at least 9 homework, because week 7 we're doing homework number 5, maybe like 9 homework. So I'm just saying, if you do well on the homeworks, and if you didn't submit any of the homework, I'm putting it on record. Those who are missing, they'll listen it. I'm assuming. So if you miss any homework, I did say at the beginning, I won't be accepting. Just giving you opportunity again. We're gonna get some points out of it. Like if it's too late, then probably we're gonna get 50% points, something like that. Okay. If it's just the latest one, probably still you're gonna lose 20% of points. But you're gonna lose points. Still, it will gonna help you big time with the grade. Uh, about exams, there are 3 total. That's what I did last year. Okay, so yeah, this Friday. No. So you are actually technically done with exam one. I don't want to say it's midterm because there are 3 exams, right? So if I'm gonna say it's midterm, then the other 2 exams are gonna accumulate it as like half of midterm or final. No. So 3 exams equal points. So this first part is done, 1/3 is done, 2 more is there. Any questions? Safar? We get okay. So you guys are doing the homework. When is the homework due? Next week Wednesday? No, this Wednesday? I should have give you the homework hints today. I don't know. Maybe I can push it to say like Thursday, I guess. How many of you done the homework? How many of you started with that? Started? Done? All right. So maybe that's the idea. So you do whatever you're doing, okay, and we'll do a workday kind of thing on Wednesday, I guess, and then submission date could be on Thursday, one day. Okay. Because I did prepare for different thing. Okay, it's a pulley problem with force, right? We did pulley problem with velocity and the acceleration before, right? So now we're gonna deal with the pulley problem with the force. So that's our agenda. Okay, that's for the actual thing. But before that, any questions so far? Everyone understand? So we're in chapter 13, and 2 more chapters probably that will be quick, right? And this is week 7, so we're in good pace. Um, any issues with understanding of anything? No. This course is dynamics. Just gonna give you a highlight. Could be a very difficult course. Okay, depending on how I'm giving you materials. Okay, if in exam I'm gonna put you like a difficult math, then it would be a really difficult math. You know what I'm saying? Really difficult course. And it could be in a social course, as long as I'm trying to do it this way. Like whatever I'm teaching, I'm trying to give it in exam and no homework. Then the life would be much easier. But just to give you a highlight here, okay? So anyway, don't want to scare you. You don't have to worry about anything. Just the way you've seen exam one, all the exams will be like that. Homeworks will be like that. So it should be all right. If you follow everything, you should be getting A from my course. There's no issue on that. All right, let's start. The lecture is on record. Again, hopefully those who are not here will gonna watch a video lecture and agenda. Okay, the first agenda here today will be dealing with this normal and tangential coordinate system equation of motion. What does it mean? We before had the normal and tangential acceleration. If you remember those, you just had the exam, right? You even use these equations and everything, like dv dt and d square over rho. Rho is the radius, you know that. And now here we'll be dealing with the same thing, but now we'll be dealing with the force. Okay, do you understand? So like force does have what? Acceleration. So this acceleration will come in play in these two components. Does it make sense? So I have some slides here. Those slides are from book chapter number 13. Okay, on this particular section, a new section. I'm gonna go through that slide. That's the first agenda, and the second agenda would be here. I do have the math problem. Okay, we're gonna do this math. Maybe we're gonna say better now. It's a pulley problem. Okay, now only difference is kind of looks the similar problem, right? Only difference is here we have to deal with the tension. Okay, even though it doesn't say tension, but I'm gonna put it here. You're gonna find the tension. Tension, what tension? Tension on the rope. Okay, we're gonna go in detail on that. But I have another thing to ask you guys. I know oftentimes I said like bright space does have everything. How many of you did actually explore the bright space? Almost everyone. And you did notice like there is everything, right? Everything means everything. All the slides, whatever I'm showing, and all the problem, like this problem that you're seeing, it is there. Not only that, we have more materials over there. Those are for you to explore more. Okay, whatever I'm covering. Okay, moving. At some point, maybe next class, I'm going to show it to you again from bright space. If you have any tiny bit of confusion what things are, okay, or end of the class, you let me know. I'm going to show it to you again. Okay, either way it will work. All right, there are some applications, and you can see those applications are kind of showing anytime you have a not rectangular, a rectilinear motion, you have a curved motion, okay, and in curved motion there are acceleration. As like in last chapter we've seen AT and AN. The same thing is here, except we are dealing with now equation of motion, means like Newton's second law, means like the force equation is going to come in play here. Any question? And the application you're seeing obviously a track here, right, Joe? On the track, it's like a curve, so there is the normal and tangential acceleration and force will going to come in play. And the same thing you're seeing in a this is probably an amusement park. What does this thing? What does this thing called? Anybody write this thing before? I didn't. I'm too scared of this thing. My son, he does love those kind of things, scary stuff. He's not, too younger than you. He's 17 years. So you guys are probably like 19-ish, right? Max 19, 20. All right. So anyway, he used to go all those things all his life. Anyway, so you see, obviously there is a curvilinear motion over there, right? The acceleration involved both AT and AN, okay, normal and tangential. Okay, so these are just the application, not that much to talk about it. Obviously, when we're going to do math, you'll have more idea about it. There's another application, obviously, a solar system we're seeing here. Okay, if you have a satellite rounding around our Earth, it's rounding, means you do have the normal and tangential component of the force and the acceleration, and then how are going to find this? Okay, this figure is kind of important here. What we're seeing here, the summation of forces in three different directions. Okay, now these two direction you guys only use here. Okay, the other one we won't be. Okay, because we'll be only dealing with this 2D case. And this is a curvilinear motion. It doesn't necessarily needs to be a circular motion. You know that, right? A curvilinear motion does have like different curves, and each curve has its own radius and own acceleration of normal and tangential components. Okay. And here another thing. Okay, if you have all those forces summed up here, and then you'll have these two AN and AT acceleration, right? And the mass, you are multiplying it to explore the right side resultant motion, and you can subdivide it into two different components, right? If the other force is absent, like only 2D case that you're considering, right? No binomial direction forces involved. If that's the case, means only 2D case, right? It's a plain case. I don't know. I mean, not that much I have to talk about here, except whatever we did learn, like AT and AV equation, AT and AN equation, we're gonna apply it in that force equation, right? Summation of force. Any questions so far? That's good. Ready for the pulley problem? Aline, you're good? Okay, perfect. The pulley problem. I do have to pull up my notes here in my phone. Okay, the notes are ready. Okay, doing this problem is not that difficult. Sorry, I'm going to put the problem first. Okay, solving this problem is not that difficult. What is difficult here is drawing the force free body diagram, FBD, drawing the free body diagram. Okay. Okay, let's first read through the problem. Obviously, determining the velocity is not everything that we are exploring. There is some correction here. So we are trying to find the acceleration AA, AB, and the tension T. Okay, what are those? Again, acceleration. This is part of the engineering format. So acceleration of block A, you may want to write that because the question doesn't have it complete. This is what you're trying to find. Acceleration of block B, block A, block B. So you're to find, and tension on rope attached with block A that's the tension you're trying to find. Okay, these three things. Okay, what are the givens? Givens are pretty straightforward. You are given with a block A weight or mass of A is 50 kg. It's a 50 kg block, right? The time value is given as 2 seconds. Block B mass is given as 15 kg. Okay? And the solution. The first part of the solution on this kind of problem is always draw the free body diagram. Now I'm going to help you with something here. Defining different length of rope of different section. Okay, so when you are considering, I would like you to name those. When you're considering on the left side of the rope, you see it's attached with a rope. It's attached with a block A. So you should be naming it what, Joe? As A or as B? As A, right? Okay. Yeah. You start to take the class note, otherwise you're going to fall behind everybody if you're not doing it yet. Okay. And then you might be noticing me putting the dotted line in the middle of the circle or middle of the pulley. There's a reason behind that. On the top of the pulley, the rope that it has, it is going to always be constant, right? No matter of what. That's why I'm ignoring that, in case if you're wondering. All right. So then, on the left side of the rope, Joe, what would you like to name it? As A or as B? As B. Perfect. Now I'm going to give you something which is, say, like from here, this to this distance. I'm assuming this is A. That's the distance. Okay. I can name it. All right. If I was going to name it this way, then, I have these three segments of the rope. Okay. Obviously, this segment of the rope, let me put it this way. You understand what is this segment? Okay. Let me do a color code. Okay. What is this segment of the rope? Is it like as B minus A? Let me do the color code again. So that's the color code, same color code everywhere, right? Didn't you understand that color code? What's this referring? Why is as B minus A? Arlene, you got it? Okay, think here. SB is the left side of the rope, right? And A is from the big pulley to small pulley C, E to C, that distance, right? So the right side, I mean, this is kind of drawing that I'm trying to put here. All right, so in the right side, right, this distance here, you see this distance? All it make sense? It's SB minus A. Okay. All right. And this is so important, man. It's so important. I mean, before this is still we are in the last exam topic. Last exam we did find velocity and acceleration from the pulley problem, right? We did how many? Even in exam we did two problems. So this kind of thing we did before, right? Two pulley problem we did. Now let's focus on that part to get the equation first with the acceleration. Okay, acceleration means we did do acceleration before. We did the velocity before, right? Velocity and the position. Remember, we started with the. Do you remember? We started the rope equation, like the position equation, right? And then we did what? One time. I didn't remember one time what did you do? One time derivation, right? One time differentiation gives us the velocity. Like ds over dt is the velocity, right? So then, if you're gonna do having another time derivative, then we should be finding the acceleration, right? It makes sense, do you know? You understand what I'm saying? So that's how we're gonna find first the total rope length equation, right? And then finding the relationship with A, B, like acceleration of A, block A, acceleration of A, block B. Understand? We can do that. And what we're gonna do with that? Because see, that will be just one equation, right, Joe? That will be just one equation. And we still have to find the tension. I haven't drawn the free body diagram for the block A and block B to find the tension, which we can focus on it a little later. But let's just write this equation, everybody. Okay? Joe, you can write that equation now. What equation you understand, right? Total rope length, if you assume, so total rope length, right? Total, if we assume is L, can you write that equation, everyone? It should be what? I would like you to try first, then I'm gonna write. Okay, think and try to write that equation. It's one of the very important thing for this math, writing that equation. Is that got it? Let me see. You got it right. You got it right. Right, you got it? Gavin, you got it? You got it right. You got it right. Got it, Alan? Take a look here. The left side, you have what? SB. Right side, you have SC, right? In the middle, you have these two small segments, right? From C to D. You see? And that is SB minus A. See, that needs to be multiplied by 2, right? Right? The middle C to D, the small ropes. Those two ropes, those two segments of the ropes needs to be counted by doing this SB minus A multiplied by 2. Okay? And that's the total length of the rope, right? Got it? Jeremy, you got it? You write the equation? Let me see. What do we have? So yeah, SN was correct, plus SB, right? And plus these two types of this, right? Alright. So very good. Almost everybody got it. Let me write it again so you guys can follow me. So you have this S A plus S B plus 2 times S B minus A. What is A again, Brett? The A is like some value that we are assuming, right? All right, and then obviously you're gonna rearrange things and then write it some more of a nicer fashion, right? SB plus 2SB minus 2A equal to L. And then you want to write this constant on the right side. You guys know that this A can be assumed as a constant. You guys know that. right? Everybody got it? Because those pulleys, that E and C pulleys, those are attached in a rigid body, right? A rod kind of a thing. So this A is a constant, right, Joe? You're seeing that A is a constant, right? Because those two pulleys are attached. All right. So then, what it means really? It means you'd like to put all the constant in one side. Does it make sense? L is a constant, right, Arlene? It's the total length of the rope. This A is a constant, so 2A. All needs to be on the right side because those are all constant, right? So if you know all of them are constant, where by the way, you should be writing, and A is the distance between pulley E and C. All right, so then what do you want to do? Can you find the relationship of velocity and the acceleration from this equation? I might have seen some of you already did it, right? So to find the velocity relationship, what you got to do? You have a position, you got to do the derivative of with respect to what? Time t, time t. So you want to do a derivative, everyone, to find the velocity relationship, and then acceleration is our ultimate goal. Okay, so just like in last class. Okay, so we'd be doing this derivative in both sides, right? Any objection? No, I didn't hear any. And now tell me how much you remember from the derivative knowledge. The right side, when you're trying to do a derivative of a constant, what is the value that you got? 0? Some of you are already showing 0, right? Delina, can you do a derivative of a constant? No. It would be a 0, right? So we do have 0 on the right side. And the left side, can I write this as VA plus 3VB? Do you guys agree with me on that? Okay, if you really agree with me on that, then if I'm going to write it this way, do you guys agree with me on that as well? Do you guys agree with me on that? Okay. So if you're trying to do the derivative of velocity, it is what? Acceleration? Acceleration of. So I can write this as AA plus 3AB equal to 0. Okay. Difficult, Arvind? No, not that much, right? It's not difficult, right? It's very straightforward so far. Okay, now you'll be feeling excited soon. I know this is so far what I've done before. Nothing new yet, but the new thing is coming now. Okay, which is the two pulleys and the forces. Okay, so what I'll be doing, I'm gonna draw two free body diagram. Everyone's done with that? All right. So I'd like to do it here in the next to it, right on the side. I can actually go below, but I don't prefer to go below. That way you can see the whole thing all together. So what I'm going to do next, I have these two pulleys. Those are attached with this block A and B. That is my goal. Okay, first let's focus on the pulley B. And I'm going to do one thing. I'm going to get a color code with a, no, sorry, not this one. I'm going to get a color code, pinkish color code that kind of matches with that. So that is that. And you see, this block is attached to this pulley. So that is my focus. Only that is my focus now. So what I'll be doing next, I'm going to draw this pulley. Okay. And I'm going to draw this block B. This is my block B, right? And I know the movement of this block is which direction? If block A is moving down, block B is moving up. All right. So I'm putting it up as well. All right. So AB is doing this way, and then on this pulley itself, I have ropes, right? I have the rope here. Let's try to do the rope in different color. These two ropes, right? And from the middle of the pulley, right, I have another rope. So I have these three ropes, and because of those three ropes attached to this block B, this block B you're gonna experience a tension for each of these rope separately. So if there's three ropes, how many T is there? If one of the rope has one T, three T's, right? So this T is the tension that you are trying to find. So you have one T here, another T here, another T here, and all of them are acting up. If one of them is not acting up, then what will happen? The block B is going to feel like slacking. Make sense? All right. So now you have this 3T, and if one of the T is not equal to another one, then we have another issues like unbalanced happen. So all these three must needs to be same. So those are the logic behind all those trees are the same and acting upward. Any question? All right. So now you understand this block and the resultant motion of the block B that is acting upward. Can you write a summation of force equation for this block? Should be right. All right. Let's start with that then. So you have this AB is acting up, right? And this block B has some weight. What is the block B weight, by the way? 15 kg. All right. Now let me write the equation for block B. Summation of Fy going upward, and then MAY. You can say ABY as well. Okay. AB and put a subscript Y that is acting on Y direction. I mean, AB doesn't have any extraction movement anyway. All right. Now here's another thing. This block is hanging on the ear. This 3 tension T acting upward. Because of the block is free falling due to gravity, there is a gravity motion as well, right? So there should be a mg acting downward. Everybody got it? So let me put it here. So there is a mg that is acting downward. What is the value of the g? 9.81. Remember that? So we're going to use that. Okay. So then can you everybody write this equation? So like on the left side, you have this 3t and this mg, right? In the right side, you have this m AB. This AB is acting upward direction, right? I know it may give you some confusion. Think this way. So this is the block B, right? I have these ropes are pulling it up. Okay, so the ropes that are pulling it up, there is this tension acting upward, and this frame has the weight, right? That is acting downward, and the resultant thing, whatever is acting up and down, resultant is the AB motion. Does it make sense?
Isn't there a tension force on the rope that connects B to the pulley?
Tension force on the rope that from here to here?
Yeah.
Yes, there is. If you're gonna, so this is an interesting question that she asked. If you're gonna cut it here, so this 3t that you have, we're gonna nullify by another 3t here. That 3t is ultimately here. Let me do another sketch to understand it better. You know, when I was undergrad, I used to do it that way. The question that you asked. So you have, if you wanna draw this thing a little differently, so like you have this pulley only and you have this block only, right? So you have this 3 tension, right? T1, T, T, T. Alisa asks a very, very important question, right? You know, when I was undergrad, I used to learn it this way. So that's how it needs to be nullified, right? And then this block now, this 3T is here, and this MG is here acting down, and this AB is the result. Now do you see that? Do you understand this? Dylan, do you understand? And that is what you can do as well, but I didn't do it that way. Just putting all things together. Okay, you can separate things. Joe, you got it? All right. So now that you have these, before you jump into doing any of these things, let me give you an overview or your motive of doing any of these things that you're doing. What's your purpose here? Your purpose here to find these three unknowns, right? What are those unknowns? AA, AB, and P. Okay. So to find three unknowns, how many equations you need, Joe? 3 equations. Number of unknowns, number of equations must be matched. Okay. So we had 1 equation already. Okay, the acceleration equation. Okay. Okay. So then we are able to find another equation by analyzing this block B only. Okay, which does have that tension T, and it does have AB as well, right? So 2 unknowns are there. So we do have now 2 equations already, but 3 unknowns. So we'll need another equations. What equation you wanna do, Brad? Obviously with block A, right? Yeah. If you're gonna do another equation with block A, then you have 3 equations, 3 unknowns. Can you solve it? So if you understand what I just said, why don't you try it by yourself? I'm doing it myself as well. You can kind of see that you're doing it correctly. If not, then you could match it with my result, and hopefully it'll going to help you. And all I'll be doing here next is just following up. You don't necessarily have to see what I'm doing. You can literally do it by yourself. And as I said, like, you can match it with my result. So I have this 3T minus this 15 multiplied 9.81, and then I have this 15 multiplied AB, and I'll just simply not writing any units for now. You can write the units still, and then this is for block B, and I'll do the similar things for block A. So block A, and I have this block A is here, right? So that one is with MA is acting downward, MAG, right, weight, and then this thing is moving down with the acceleration of AA, and there is this tension that is acting on the top of it. Okay, now can you tell me, I know you guys are working on it, can you tell me for block A what is the tension value? Just 1T? Why? Because take a look here on the left side of this pulley, right, you have this T, right? Able to see that? Yeah. What happened here? No, not the left side one. I'm sorry. Okay, let me do it on the left side one, not the right side one. I'm sorry. I was telling it right thing, but doing it wrong thing. So on the left side, you have this one rope, and that one is this rope. Okay, I'm trying to do now the color code. Do you see? Okay, so now on the top there is another pulley, and this one is gonna come here, and I'm gonna do just the color code, right? Do you see that? So if that one is T, this one is T, this one is T, this one is T. You see that? I'll let you understand. Right? You see the top pulley here? It has a left side of the rope and the right side of the rope. Right side of the rope is attached with the block A, right? So in the left side of the rope, in the top pulley, has a tension T, and you have seen it from block B free body diagram, right? The pulley diagram. So that's the reason you have the same T on the right side of the top pulley, and that will gonna be actually for block A as well. Does it make sense now? Did you got it?
So if you were to do block A first instead of block B, would that change anything or no?
Yeah, no, it don't, because you see, if you want to do block A and then you'll have equation which has a relationship with t with a. A means acceleration with a, right? And then you have again just two equations. One with the a equation, the left side, and another a. You have three unknowns. You need another equation anyway. So you're gonna do block B anyway, right? Three unknowns, three equations. You got it? And that's it. As I said, like I do have the final answer in case you found it. The results would be a little difficult to find. It should be 2.85 for A B. A is 8.55 and T is 63.29. So I'm writing those values. So AB is 2.89. I intentionally leave these things empty. I'm hoping you guys are doing it by yourself, right? Okay, write the equation for block A and then solve it. You understand what I'm doing? And then 8.55. This is meter per second square. Obviously, everything is in SI unit. I didn't write any unit in equation B. Don't get confused. Everything is in base unit, SI unit. Okay, and the T is in Newton, obviously, and the value would be 63.29 Newton. Okay, so these are the values you should be finding. And don't worry, I'm gonna start writing this thing after 4 or 5 minutes. Okay. In the meantime, you'd like to solve it by yourself. Okay, all of you. Solving three equations for three unknowns can be a little tricky to do, okay, but not impossible, okay, by hand calculation. But in some calculator, it can do it by itself. If you know programming language, it can solve the values for you. Nowadays, then because of the AI, if you can just plug those equations in Google and ask the answer, it will give you the answer as well. But bottom line, it is possible. Okay. Third equation, by the way, I didn't write it yet. Right? Did you know? Can you write that equation? Third equation for block A. Just the way I write the equation for block B. Can you do that? I have the Fibonacci diagram though. That should help you, right? You have the tension T acting up. Mg is acting down. In the left side, you want to write what? T minus Mg, right? Which am? Block AM, right? You know? And the right side, you want to write what? MAA, right? That's the third equation. Why don't you try that? So all three equations you want to write and then start to solve and see if you get these values. Okay? If you get these values, that means you're in right track. If you're not, that means most likely you did a calculation error. Nothing major. At this point, I should be writing that equation, the block A equation. So the block A equation should be T minus MAG MAAA. And then this T is not known. This is known. This is known. Okay, and you can further deduce it, obviously 3t here. 147.15 15 AB, then you want to write this thing divided by 3, so t minus 49.05 5 AB, and that you would like to write it as equation number 2. All right, this thing is a little weird, like, you know, this is a little small, the equation 1, because I did write it first and then I didn't follow up on that much. All right, so this t minus, you have this 50 multiplied 9.81, which would be 490.5, then 50 AA. All right, and several ways you can solve it actually. You have a relationship with AA and AB. You may want to use it here to get a relationship of those two, like, you know, this is equation number 3. So this is the final result. I'd like to box them. And I don't know how you are solving it. You guys are doing it in sets of equation in calculator, okay, and got the same value that I wrote. If you got the same value, then you are done actually. I mean, I can do a quick recap what we did. We had a pulley problem here. We had obviously 3 unknowns, A, B, and T. A, B is the two acceleration of block A and block B. T is the tension, right? And then we had those 3 equations. When we had 3 unknowns, 3 equations, then we know how to solve it by solving the set of simultaneous equations. And finally, we have the accelerations for block A, block B, and the tension T for a row. Uh, Oh, that's 50 as well. This is the same block, yeah. You're talking about the middle equation or the last equation? That's the equation. The middle one is 15. 15? Yeah. The middle one is 15. Oh. Yeah, because block B is 15 kg and block A is 50 kg. The right side one is 50. Okay. I know. Are you referring to this? This is 50 and this is 50. 50. Okay? This is 50. Don't worry about that. This is the final equation. Use that one. Okay? This is the final equation. Use that one. Okay? I did do the math. Lisa, you're getting it?
I'm not doing it.
Okay. All right. So, so equation 2. So plug AB so equation 3 plug AA equal minus 3AB. And this equation can be written as 4 minus T minus minus this 50 multiplied 3 AB. So you have this tension T plus 150 AB 490.5. This one is equation number 4. So you want to compare equation number 4 with equation number 2. So equation number 2 is T minus 5AB equal 49.05. Okay, that's equation number 2. So from these two equations, what do I do? You find the value of the A, B, and T. I'm just showing manually how you're going to do it in calc. Is it calc or pre-calc? Or even it's before basic algebra? It could be basic algebra, right? So way before that you did it. But okay, it's all right. So this two will going to cancel out. We're going to have 155 AB equal 49.05, 539.55, I don't know, divided by 155. So Logan, you got the values like this that I put the result exactly like that. I'm not getting it though. Maybe I did something wrong in the calculation somewhere. That means these values are correct. Okay, there's something wrong in my calculation here. I got to check now. So T minus
490.5 minus 49.05, right? Not adding.
Oh, I'm adding. Yeah, that's the reason. Thank you. This is because of the calculator. So 490.5 divided by 49.05, 441.45, and then when we're going to divide this by 155, yep, thank you very much, 2.89. Okay, Lisa, you got the value now?
No.
What is happening? Either AV value you found this way, or
I did it doing the tension force first, and my tension force is not correct.
it could be a calculation error. Don't worry, you can do it at home again. You have the final results, all three of them. Did you know you can do it from here? What are you going to do now? You have the AV value, you want to plug this value to equation 2 or 3, either one, whatever you like. Right? To find what? To find the value of the tension, right? Once you have the tension, and then AA, finding AA is super easy, right? Because AA is, there is a negative. AA result should be negative, right? So 3 multiplied A, 2.89 multiplied 3, which would be 8.55. There is one thing that you want to do. Just use this as Oh, Alisa, I know why you are not getting it correctly. Just 1 second. Everyone, so I did some error. There's a mistake I did. You see this AA here, that should be negative. So this is why this is X direction, right? Right, you understand? So there's a mistake. So it should be negative. It should be negative here. It should be negative here. Then do the math, okay? Okay, everybody correct it. And solve it in next class, okay? All right, I'm leaving now. Good?
Yeah.
All right, and next class we're gonna follow up on that, okay?